What we are going to do today is to do the same in cylindrical coordinates, okay, because finally we want to do flow through a pipe, okay, and that's a very important problem. But we should know what are the governing equations in various coordinate systems, because then we can try to attempt various geometries, okay. So what we did in the last class was the simplest of the case, where you deal with a Cartesian coordinate system, and then you could therefore solve for the flow profile in a 2D channel. And you do know that the governing equations look a bit different when you are in other coordinate systems. So let us just look at why it happens so before we actually attempt to solve the problem in a pipe. So what we are going to try doing today is to find out how do we find out what is the right governing equation in various coordinate systems. So we will use cylindrical coordinate system as an example, because that's going to be most useful for this course. So what we have is a Cartesian coordinate system. Let's start with that, because that's the most familiar case. Okay, so you have x, y, z, a right-handed coordinate system, and any point that you look at, you will describe that point using a x, y, z, right? That's actually what we meant by Cartesian coordinates. Now in cylindrical coordinates, we want to replace it with an r, theta, z. Okay, how does one define r? The way to define r is to project this point onto the xy plane. Okay, and this distance is what actually is known as r. Okay, and how does one define theta? Theta is essentially this angle. Okay, so that means that z, so things are changing, so really you have z in the Cartesian coordinate system remains at the same z in the cylindrical coordinate system. Instead of x and y, you are going to use r and theta to describe any point. So r is going to tell you what is the radial distance from z axis. So that's the z axis. It tells you how far radially it is from z axis. Theta is going to tell you if you were to have an x axis, how much rotated it would be. So therefore r and theta will give you the same information as x and y give. That's clear? So if you look at just xy coordinates, so we can just since z is not changing, we can actually look at all the analysis by looking at the xy plane. So we'll just draw xy plane. That's our x, that's our y. Any point that was actually described using xy, we are going to change it into r theta coordinate system. So that's going to be our r now, and that's going to be our theta now. So if this point was denoted using xy, then what is the relation between x, r and theta? X is equal to r cos theta, y is equal to r sin theta, and z will just remain as z because nothing has happened to z. All of you know that, okay, and there is no problem with that. Now the important thing is to realize what happens to the unit vectors in these coordinate systems. So in Cartesian coordinate system, if I have a unit vector that I denote using x cap, here a unit direction y cap, and this is z cap, any vector that I talk about, I can resolve it into components in x, y, z direction. You all know that, okay. Now what we really need is, when we have a vector, we also need to resolve it in r direction, theta direction and z direction if we want to really make use of cylindrical coordinate system, okay. So therefore we need to define unit vectors in r theta z coordinate system, which is going to be simple, because this is your r and then what you are defining r is essentially the distance from the z axis to any point. Okay, so r is really that. Okay, so r cap, if I define, r cap is just going to be a vector, okay, a unit vector which tells you, you know, what is the direction in which your radius is going. So it could be, so this is right now in this plane, yz plane, r cap would be like this. If I talk about an xz plane, r cap will come out of the plane, and so on. You understand that? So if you have an z axis, r cap could be in all these directions, just the way you have radial directions going away. Okay, and theta cap is basically the direction in which theta is changing. So theta cap would be something of that sort. Okay, a unit vector that's defined in the theta cap direction. So imagine my hand is the z axis. Okay, r cap would change like that. Theta cap is going to tell you how things are changing in this direction. So this can be, so if I am looking at this point, theta cap could be a direction. If I am talking about a point here, theta cap will be this direction, and so on. Okay, so r cap is the unit vector that's coming out of z. Theta cap is going to tell you how things are going to change this way. Okay, and z cap of course will remain as usual along the z axis. So those are the unit vectors in cylindrical coordinate system. Okay, now what we are going to do is we are going to connect this unit vectors in cylindrical coordinates with unit vectors in Cartesian coordinates. Okay, so that's going to be a useful, that's going to give us useful relations. So again we can just stick to the xy plane. So x, y, the point at a distance r at an angle theta. So by definition, that's my unit vector r cap, that's going to be my unit vector theta cap. This is how x cap would have looked like, that's how y cap would have looked like, and this angle is going to be theta. All of you agree? So then how can I write down r cap? R cap is a unit vector. So if I finish the triangle, this length is going to be just cos theta. This length is going to be just sin theta. So if I do cos theta x cap plus sin theta y cap, that's just going to give me r cap, right? So it's nothing but cos theta x cap plus sin theta y cap. Agreed? So what is going to be then theta cap minus sin theta x cap. Minus is because x cap is in this direction, so you will need a minus x cap in this direction, and then plus cos theta y cap, and z cap again is z cap. So this is how the unit vectors in Cartesian directions are related to the unit vectors in cylindrical coordinates. Is that clear? Okay, so then now write down what is x cap and what is y cap. You can write down using the same thing, or you can solve these equations whichever way you like. You can multiply the first equation with cos theta, multiply the second equation with sin theta, add up, and you will get x cap, and the other way. Okay, and y cap? Yeah, so that's basically the relation, the inverse relations. So now we know, given Cartesian coordinate system, how to convert it into cylindrical coordinate unit vectors and the other way. Okay. Now, so these are just some relations that we need. The most important difference, okay, that make Cartesian coordinate system different from all other coordinate systems is this. What is del by del x of x cap? That's when I am moving along the x direction, how does my unit vector x change? Does it change? It just does not change by magnitude, by definition, and it does not change the direction, so it's 0. what is del by del y of x cap? If I am moving in y direction, does anything happen to my unit vector x cap? No. Del by del z of x cap, again 0, and so is true with whether I use y cap or z cap. In other words, none of the unit vectors, okay, there are no gradients. Whatever differentials I am going to take, it's all going to be 0. Okay. That is not true in any of the curvilinear coordinate system. So why I am saying that? Let's say this is my z axis. Let's say this pen represents my r cap. Okay, if I am changing in this direction, my r cap direction is changing, right? When I am going like this, I am going in theta direction. When I am going in theta direction, so if I have a point here, this is the direction in which I have defined my r cap. If I go to a different point, my r cap has changed the direction, even though its magnitude has not changed. Okay. So that means that if I am looking at the derivative of unit vectors, that need not be 0, the way we have written it down for the Cartesian coordinate system. So we need to actually find out how unit vectors change when I go in different directions. Okay. And that's important because we talk about all differential equations, we talk about spatial gradients, we talk about divergences, curls and gradients and so on. So the change in unit vectors therefore become important. That's clear. So let's calculate that. It's very easy. So we want to first calculate, let's say, del by del r of r cap. Okay. So we know the relation, we can use the relation r cap is cos theta x cap plus sin theta y cap, theta cap is minus sin theta x cap plus cos theta y cap. So del by del r of r cap, I can take a derivative of this, del by del r of cos theta x cap plus sin theta y cap. Okay. Now theta is not a function of r. By definition, theta and r are two independent coordinates. X cap and y cap are constant unit vectors. So this is basically a constant as far as r variation is concerned, and therefore that is equal to 0. Del by del r of r cap equal to 0, and that has to be the case because if I define an r cap like this, if I go in this direction, the unit vector is not going to change. Okay. So del by del r cap is 0. Now let's do del by del theta of r cap. What is del by del theta of r cap? Again we can do del by del theta of cos theta x cap plus sin theta y cap. X cap, y cap are constant unit vectors, nothing to do, but theta is there. So that gives you minus sin theta x cap plus cos theta y cap. Agreed? What is minus sin theta x cap plus cos theta y cap? Theta cap. So we found that del by del theta of r cap is equal to theta cap, which is different. Del by del z of r cap, del by del theta of no, let's do the other one first. Del by del r of theta cap, del by del theta of theta cap. I'll take a moment. Sunil Kumar, what is that? Minus r. R cap, no? Del by del z of theta cap, 0. Del by del r of z cap, 0. Del by del theta of z cap, 0. Del by del z of z cap. Prekna, what is del by del z of z cap? The last one. Oh, my handwriting is not clear? Okay, so I meant to write del by del z of z cap. Okay. So, this is basically how the unit vectors are changing in the cylindrical coordinate system. Okay. So, there are two non-trivial quantities. One is del by del theta of r cap, another is del by del theta of theta cap. Okay. And that can actually bring in some additional terms whenever you talk about spatial gradients. That's okay. Any doubts? So, we are going to derive now gradient operator in cylindrical coordinates. Abhiram, what is gradient operator in cylindrical in Cartesian coordinates first? Something is missing in that. Yes. So, x cap del by del x plus y cap del by del y plus z cap del by del z, right? So, x cap we have derived it as r cap cos theta minus theta cap sin theta into del by del x of something. Okay. So, there you need to now convert them into del by del r and del by del theta and so on. So, what can you use? Chain rule. So, let us use that. So, del by del x is equal to del by del r into, in fact, I should write the other way, del r del x. Yeah, del r by del x into del by del r plus del theta by del x into del by del theta plus y cap is given as r cap sin theta plus theta cap cos theta into del by del r by del y into del by del r plus del theta by del y into del by del theta plus z cap into del by del z. That is equal to, now we need to know what is del r, we need to know these quantities. Okay. What is del r by del x? Any doubt on what I am doing? So, I have just written down the gradient operator in the Cartesian coordinate system. I have converted all my unit vectors using the relations that we just derived, and each of the gradients are written in terms of the partial, in terms of other partial derivatives in the cylindrical coordinate system using chain rule. Okay. So, now for example, I have del by del x, expanded it using r and theta and so on. Now, we know that we need to calculate del r by del x, del theta by del x, and these two quantities. We know that r square is equal to x square plus y square. Therefore, if I want del r by del x, 2r del r by del x is equal to 2x, or del r by del x is equal to x by r, and x by r is cosine theta. What is del r by del y? Mesiva? Sin theta. Now we need del theta by del x. So let's do it here. Theta is tan inverse y by x. So del theta by del x would be 1 divided by 1 plus y square by x square into y to minus 1 by x square. So that's going to give you minus y divided by x square plus y square, or minus y divided by r square can be written as minus 1 by r into y by r is sin theta. Correct? What is dou theta by dou y? What is del theta by del y? 1 by r cos theta. Yeah, that's right. So now we can substitute and we can simplify. Let's substitute and simplify. Okay, I'll just rub these. R cap cos theta minus theta cap sin theta into del r by del x is cos theta del by del r plus del theta by del x is minus sin theta by r minus sin theta by r del by del theta plus r cap sin theta plus theta cap cos theta times del r by del y is sin theta del by del r plus cos theta by r del by del theta plus z cap del by del z. Is equal to expand. This is cos square theta r cap del by del r minus r cap cos theta sin theta by r del by del theta minus sin theta cos theta theta cap del by del r plus theta cap sin theta by r sin square theta by r del by del theta plus r cap sin square theta del by del r plus r cap cos theta sin theta del by del theta plus theta cap plus r cap sin theta cos theta by r del by del theta plus theta cap cos square theta by r del by del theta plus z cap del by del z. And that one and this one will go, this one should go. So this should have been del by del r. So that's the first term, yeah. Del by del r, that should go, and you have a del by del r term here. Here, adding them up, you get r cap del by del r. So this and that, this and this should give you theta cap divided by r del by del theta plus z cap del by del Z.